Right guys, okay, so we're nearing the end of our unit on acid-base equilibria, and we need to know about the enthalpy of neutralization of acids. And in particular, what we need to understand is that there is a difference in the enthalpy changes of neutralization between strong and weak acids. So let's start off by looking at the enthalpy of neutralization of a strong acid and a strong base. Okay, so here we go. Let's pick one that we know. There we go. And the enthalpy of neutralization for this is roughly always around minus 57.2 kilojoules per mole. So that's exothermic. These are our spectator ions, so we're going to get rid of them, and we're going to write out the reaction that's actually happening, which is that one there. So this is our first reaction here. Strong acid, strong base. And the next one is weak acid, strong base. And it's different. And we need to know why it's different. Okay, so let's pick a weak acid that we all know. Let's pick this one. You got it? Ethanoic acid. Sodium hydroxide, strong base again. Sodium ethanoate and water. Now this reaction, we have to look at it in terms of its enthalpy change in two stages. The first stage is the ionization of the weak acid, like so. I'm going to call that delta H1 because there is an enthalpy change when this happens. Now once this has happened, we've got our acid which can be neutralized. In the same way as above here, and we're going to call this delta H2. So it means that the delta H of neutralization for this reaction here, weak acid, strong base, is equal to delta H1 plus delta H2. And delta H2 is always roughly that value there. Now the thing is that this first reaction here can be endothermic or exothermic, and that changes this value. Okay, so let's look at let's imagine this reaction is endothermic, and let's give let's give it a value, or let's say it's endothermic. Let's give it a value of plus 5 kilojoules per mole, plus minus 57.2, and that will give us minus 52.2 kilojoules per mole. And the point here is that if the weak acid strong base reaction occurs and this is endothermic, then the value that you get for the neutralization is going to be less exothermic than the value that you get for a strong base, strong acid. Okay? Okay, now let's imagine that this first reaction here, delta H1, is exothermic. Let's give it a value of -5. It's going to give us -62.2 kilojoules per mole. And the point here is that this value here is more exothermic than strong acid, strong base. And this is the reason, this is the explanation why you get different neutralization values with a weak acid and a strong base. It depends whether this first reaction here is exothermic or endothermic, and that is the difference. Okay, so that's that one. Okay.